last one, I remember completing speed. Right. So this week, what I'm going to do is I'm going to do some problems for second chapter. It is still the first. Right. I'm not going to start the new chapter for now. If you all get an message regarding the cumulative piece for the first chapters, you have to for last week. This one, this week, not about this week. After after vacation, you will have both the chapters combined. Got the message? Okay. So this week, test, right? Whatever has been taught, there is nothing like repeated. Whatever I'm teaching you here, you be tested. Because we don't know what they have been asked in the exam. It's better to be on the safe side. So basically, what we doing in the previous class, where we really problems from second chapter. You were right. Okay. So I have one thing. For today, see, for today, I'll be discussing the first test paper. Tomorrow and day after tomorrow, I'll solve some problems based on second chapter. Okay. So concepts are over or not? That's what I need a confirmation, because for the other batch, I remember completing. Is there anything that I've left? Did I give you the table? The table, and I told you how to solve problems, right? Okay. Okay. So today we'll discuss this paper. Those who are online are able to see?
Yes, sir.
Okay. See, what is the answer for the first one? What is the answer for this one? So when a negatively charged conductor is connected to Earth, so let's try to understand why the other options are wrong also. Okay. So what is the first one? Electrons flow from the Earth to the conductor. If that had happened, then what would have happened to the conductor? It would have got even more negatively charged. So read the option. No? When a negatively charged conductor is connected to Earth, if at all the electrons were to flow from the Earth to the conductor, what would have happened to the conductor? It would have got even more negative charge. It would have got more negative charge. So this is wrong. Secondly, when you connect a charged conductor to the Earth, there should be flow of charge. There is no possibility that no charge is going to flow. So this is also wrong. What about this? Protons are going to flow from the conductor to the Earth. This could have happened, or this could have happened. Electrons flow from the conductor to the Earth. What will happen? So the Earth will take the excess amount of charge that is present in the conductor. So this is also not going to happen. So this is the right option. Right. I'm sure most of you would have chosen this only. But did you understand why the logic is that? Here. Next. This is a simple question, right? An electric dipole placed in non-uniform electric field experiences. So both torque and net force. What about this? No torque and no net force. When will this happen? Let's try to answer this. When where should an electric dipole be placed so that this is not occurring? No net force is occurring, at the same time no net charge is also. That's right. So it can either be in the direction of electric field or in the direction. The dipole moment can either be in the direction of electric field or in the direction opposite to the electric. So this would have occurred when you have a uniform electric field and you place a dipole either in this orientation or this orientation. In both the scenarios, what will happen? There is no torque and no net force. So when there is no net torque and no net force, I'm going to connect the dots. Listen to this carefully. When there is no torque and no net force, what is this condition called as? You call it as equilibrium. So in the second chapter, we discussed the concept of equilibrium at one point. Where was it? When we discussed about work done. You will get this kind of question this week. So work done is equal to, or potential energy is equal to what? There is something like minus PE cos theta. You remember this? Right? If not, you can check your notes. So the potential energy that is stored in a dipole, which is placed in uniform electric field, is going to be minus PE cos theta. From this, we will be discussing about two types of equilibrium. What are they? One is stable and the second is unstable. Forgot everything. Huh? So remember this. When will you call it as stable equilibrium? In this case, when will you call it as stable equilibrium? When the value of theta is 0 degrees. When will you call it as unstable equilibrium? When the value of theta is 180 degrees. You're clear with this, right? So this is what will happen. So this is not the answer. Sorry. I'm just trying to give you the meaning of other statements. Is that clear? Right. Only a force but no torque. When can this happen? There will only be force, but there is no net torque. Sorry? I didn't get you. When you place it in uniform electric field, what exactly happens? Is it this scenario? When you place a dipole in uniform electric field other than 0 degrees and 180 degrees, what would happen? What will happen to it? There will be torque but no force. That is the answer for the fourth one. So this will not occur at all. You cannot create a scenario like this. And what about this? When you place it in uniform electric field. So that is why we need to be clear with the question. Here they have clearly mentioned it is a non-uniform electric field. So both torque and net force is going to be non-zero values. I hope I'm clear with this, right? Shall I proceed? So the dielectric constant K of an insulator can be. Now you know what is the dielectric constant, right? What is it? Dielectric constant, we can also call it as relative permittivity, which is defined as epsilon divided by epsilon naught, right? So what can be the values of Kb? It will be greater than 1 because the permittivity of any medium is always greater than the permittivity of free space. So when the numerator is greater than the denominator, none of these values will match. So you can make a note of this. Epsilon is always greater than epsilon naught. This is the reason for it. Clear with this? Shall I proceed? Because it's not defined it. It's not defined. Infinity doesn't mean it's a very high value. It's not defined. You cannot define dielectric constant because the name itself is suggesting no dielectric. You cannot define it. So in that case, we are getting K is equal to 1, right? See, sometimes we get, when K is equal to 1, you get epsilon is equal to epsilon naught. For which medium will it occur? For air and vacuum. Remember that air and vacuum are also not perfect conductors. So infinity, I told you, for a perfect conductor. Okay. This one. Two infinite plane parallel non-conducting sheets separated by distance d have equal and opposite charge densities sigma. Electric field intensity at a point between the sheets. So due to the positive sheet to the right, what is going to be the value? Very good. So where did we apply this concept in the second chapter? We used this concept, no? Where did we use it? Parallel plate capacitor. So here also it is going to be sigma by 2 epsilon naught. When you add them, answer is going to be sigma by epsilon naught. Depends upon the location of the point. Is it right? So does the electric field due to an infinite plane sheet depend on the distance? Right. How will the graph be? When you draw the graph for electric field as a function of displacement or distance, how is the graph going to be? It will be a straight line parallel to the x-axis. So what does this indicate? It indicates that the electric field due to an infinite plane sheet is always a constant, right? So the statement is wrong. Sigma by 2 epsilon naught. This would have been correct had the question been only due to one plane sheet. This is also wrong. 0. This would have been the answer for outside the non-conducting plates. So at this region and the third region, the electric field is 0. Hence, the right option is sigma divided by epsilon. Right. Next one. If the amount of electric flux entering and leaving an enclosed surface are phi1 and phi2, then the electric charge inside the surface is how much? Which one? Phi2 minus phi1 or phi1 minus phi2? Why? It's considered to be negative. What is the reason for it? You know the answer, think. I've told that many times. So which charge has a tendency to receive the electric field? Negative charge. So when you have negative charge, this is the direction of electric field. But irrespective of whether you have a negatively charged surface or a positively charged surface, the aerial vector is always going to be the outward direction. So when electric field and aerial vector in opposite direction, the angle between them is going to be 180 degrees. So because of that 180 only, you are getting the negative value. It's not a notation that we have fixed. It is coming because of the definition of flux. Okay. So phi1 here is negative. Here it is positive. So what will be the answer? Phi2 plus phi1 into epsilon naught. When will this be the answer? This would have been the answer had the flux due to two charges were leaving from the surface. So this is wrong. Phi2 minus phi1 divided by epsilon naught. What have they given? What quantity is this? Is there any quantity that you know which is flux divided by epsilon naught? No, right? Rather, what did you see? What is the expression we generally see? Something divided by epsilon naught. What is the something in the numerator? It is not flux, it is charge. So this is also wrong. This was given only to confuse you. See, they both are looking similar. What about this one? This also does not exist. There is nothing like flux divided by epsilon naught. What about this? This is the right one because phi2 is positive and phi1 is negative. I hope it is clear. So next time, I want you to remember this logic. Why is it negative? Because of the angle between the electric field and the aerial vector. Okay. Shall I proceed? What is the answer for this one? Eight dipoles of charges of magnitude E are placed inside a cube. Right. The total electric flux coming out of the cube will be very simple. 0. So whenever you place a dipole inside a closed surface, the total charge enclosed due to the dipole is going to be 0. See here, what they did is they gave this E to confuse you. Most of them will think that it is E by epsilon naught. What is the meaning of this statement? 8 dipoles of charges of magnitude E means what is the meaning of it? The positive charge and the negative charge both have the same magnitude of E. That is the meaning. Okay, not the total charge is going to be E. Am I clear with that? So what will be the total charge of a dipole always? The total charge of a dipole always is 0. So whenever a dipole is placed, not only one dipole, even if you place 10,000 dipoles inside a closed cube, the answer is going to be 0. Because the total number of field lines going out will be equal to the total number of field lines that is going to enter. So based on that logic, you can use this logic also. The previous problems logic. See, this is another way they can state it. If they ask you what is the reason for it, let's say the same question comes in assertion reason. So what will they state? They'll say that the total electric flux coming out of the cube will be 0. That's the statement. Is that right? So in the assertion, they say 8 dipoles of charge of magnitude T are placed inside the cube. The total electric flux coming out of the cube is 0. Is the statement right? Assertion is right. So what should be the reason to be given so that assertion and reason are right and the reason supports the assertion? What should be the exact statement they should give? The total charge enclosed within the Gaussian surface is 0. That statement should be there. You should see the word total charge. Okay. What about this one? There is a textbook problem. A point charge of 2 microcoulomb is placed at the center of a Gaussian surface, 9 centimeter. So there is a Gaussian surface which is a cubic structure which has the edge to be 9 centimeter. The side of the cube is 9. Right. So what is the net electric flux through the surface? Simple. What is the answer? What should be the answer? So what is the formula for net flux? 2 into 10 power minus 6 divided by epsilon naught is 8.85. So how much will be the answer? How much will be the answer? So you can cancel this how many times? So this becomes how much? 8.85 divided by 2 is how much? Okay, you did 2 by 8.85. How much is answer coming? 1 point. Is that what everyone got? Don't remember. Okay, but now you know, right? So here, what is unwanted data? This thing they gave only to confuse you. That's not needed at all. I'm not sure what is the answer. I think it is 1.7. Answer is 2.261. The calculation part I'm not checking. I hope you're getting it. 2.26 into 10 power 5. So that's the answer. But the logic is q divided by epsilon naught. So assertion reason. A point charge is lying at the center of a cube of side L. The electric flux emanating from each surface of the cube is 1/6 of the total flux. Is that right? Yes. So we did a problem from textbook also. You remember that square thing would have been given. There'll be on charge. You need to consider a cube. You remember that? So that problem only. So according to Gauss theorem, total electric flux through the closed surface enclosing a charge is equal to 1/epsilon naught times the magnitude of the charge enclosed. Is that right? So are both right? Is reason supporting the assertion? Is the reason supporting or not supporting? Why? What is given? Okay, not supporting. Why? See, this is where you make mistake. No, see here, it appears as if this is supporting it. If you're able to choose the right option between A and B, you can solve the problem. If none of them are the case, you can choose C or D. That's easy. The tricky part is only between A and B. In this case, how did you say it is not supporting? Like what made you state it? That's what. What is the keyword? That keyword is what I want. I want to know how you thought of. Okay, by reading you told you understood. If I ask you to correct the reason so that it supports the assertion, how will you correct? Adukku munnadi question paravalla. That was easier. Sorry, ma. That should have been given. So here, if you see, you need to concentrate on subject. Treat it like English. Here, what is the subject in the first part? The subject is a cube. The second part, what is the subject? It is Gauss law. So if you look from the cube's perspective, this is right. If you look from the Gauss law's perspective, this is also right. But they are not speaking the context. They should have told the cube has 6 sides and the flux that is getting emanated from one of the sides is 1/6 of this epsilon naught with the support of Gauss law. You're able to understand? That is why this is the trickiest part. So you should always concentrate on what the subject is. Right? So that is why the answer in this case is B only. Did you all understand? Right. So make a note of it. Those who are online are able to understand.
Yes, sir.
Yeah. Shall I proceed? So what about the 9th one? So a charged particle free to move in an electric field always moves along the line of electric force. Is that right? Okay. Second one is the electric lines of force diverge from positive charge and converge at a negative charge. Is that right? A reason you are thinking it is right. Okay. This is correct. Okay. What about the assertion? A charged particle free to move in an electric field always moves along an electric line of force. Is it? It appears to be right for me. You guys wrote this, no? You didn't even check your answers back. What is the answer for that? You got it wrong. Now at least try, no? For me, it appears to be right. If you think I'm wrong, please correct me. Let's have a discussion. Read the statement carefully. Don't read அப்படியே சந்திரமுகி படம் பார்க்குற மாதிரி அப்படியே பார்த்துட்டே இருக்கு. ஒரு பெண்ணை வச்சு draw and see what has happened. Is that right what they are trying to say? ஒரு electric line of force இருக்கு. Okay. There is a charge. They are saying the charge will move along this line. Is that right? I gave you a hint there. How do you define or how do you choose that this is the direction of electric line of force? How did they know that electric lines of force always diverge from the positive charge and converge at the negative charge? So what is the test charge considered to be? Positive. Had you considered the test charge to be negative, things would have been different, no? So this statement is right only. The electric lines of force diverge from positive charge and converge at negative charge. This is universally accepted. Because by default, we take the test charge to be positive only. But what about this thing? A charged particle free to move in an electric field always, this is what they're emphasizing on, always moves along an electric line of force, need not be. Only positive charges will move along the direction of electric lines of force. What about the negative charge? This we know, they move the opposite direction, right? So the statement is wrong. It is wrong. So what is the right answer? I told you, no, if either of them is wrong, C or D, you can choose it. It's simple. The only tricky part is between A and B. So whenever you get stuck between A and B, what is it you need to concentrate on? I told you, concentrate on the subject they're trying to speak about. Okay. So if the subject is not matching, then answer is B. If it is matching, then the option is A. Shall I proceed? Section B. See, what is meant by quantization of charge? What is its cause? So what do you mean by quantization of charge? The total charge is always an integral multiple of the charge of an electron. So what is the cause of it? So obviously what can happen? Only an integral number of electrons can be transferred from one material to another. And this is applicable only for what kind of objects? This also I told you. I asked you to make a note. It is applicable only for microscopic objects. For macroscopic objects, the number of electrons that are getting transferred will be very, very, very high. Okay. So this is the reason. So quantization of charge is a property due to which, see, you need not write all these things. Quantization of charge says that the total charge is equal to an integral multiple of the basic unit of charge. So what is the basic unit of a charge? Basically, we say it's an electron. But if you see in terms of magnitude, you can say proton also. Okay, shall I proceed? So there are 2 point charges, 4 microcoulomb and 1 microcoulomb, which are separated by distance of 2 meters in the air. Find the point on the line joining the charges at which the net electric field of the system is 0. So where will it be 0? So similar kind of a question is there in the second chapter also. How is the question framed? They'll ask you. So from my context, listen to the context. You have similar kind of a question. They'll give you 2 charges separated by a certain distance. What will they ask you? Find the point on. I told that question is important also. Find the point on the line joining the charges where the electrostatic potential is 0. So for electrostatic potential, what is the condition I told you should exist? If at all you have a system of 2 charges and you want to find a point on the line joining the charges where the electrostatic potential is 0, then the charges are supposed to be of unlike charges. They should be of opposite nature. Whereas if you look at this question, right, what are they saying? What did they give? They gave similar, they gave like charges, right? For like charges, is there a possibility where the electric field can be 0? That's what we need to think of. So where will it be? Let's think of the logic, okay? So there are 3 regions. So where did they find a point on the line joining the charges? So that is along the axis only. If I take this to be P, due to this positive charge, electric field is in this direction. Due to this positive charge, electric field is in this direction. Is there a possibility for them to get nullified? Means for them to get cancelled? So the point cannot be on the left of both the charges. What about right of both the charges? If I take this to be R, electric field due to the first charge is going to be to the right. Electric field due to the negative charge is also to the right. They also get added up. So this is also not possible. So what should happen? They should be in between somewhere. So that the electric field due to the first charge is to the right and the electric field due to the negative charge will be to the left. So that E1 vector plus E2 vector is going to be a null vector. Right. So if I write it in terms of magnitude, can I write E1 is equal to E2? Right. What is the value of E1? K Q1 divided by R1 square, or I'll call it as R square. K Q1 divided by R square is equal to K Q2 divided by 2 minus R the whole square. So K and K will get cancelled. What is the value of Q1? 4 by R square is equal to 1 divided by 2 minus R the whole square. So what I supposed to do? Just cross multiply. So 4 into 2 minus R the whole square is equal to R square. So it is 4 into 4 plus R square minus 4R is equal to R square. So when you solve this, you get 3R square minus 12R plus 16 is equal to 0. 3 into 16 is 48. So how will you split 48 as? No, 16R. So 16R means correct. 16 is correct, no? Yes. So 3R square minus 16R plus 16. So 3 into 16 48. How are you going to split that 48 so that the sum of these terms gives you minus 16? So you can write it as 3R square minus 12R, sorry, 12R minus 4R plus 16 is equal to 0. So 3R into R minus 4 into R minus 4 is equal to 0. So R will be 4 by 3 or 4. So which is the right answer? What is the right answer? 4 by 3 or 4? So because I took R from here, when I say the distance from here is 4, it is greater than 2. When it is greater than 2, it will be somewhere on the right of both the charges. So this is not possible. Whereas when I take 4 by 3, it is 1.33, which is less than 2. So it's in between. So that's the right answer. Okay. Sorry, guys. Did you all copy it? So what about this one, 12th one? Given a uniform electric field of 5 into 10 power 3 I cap Newton per Coulomb, find the flux of this field through a square of 10 centimeter whose plane is parallel to the YZ plane. So when plane is parallel to the YZ plane, what is going to happen to the aerial vector? What is the direction of aerial vector? This I already told you. So you need to take the XYZ space. When you talk about YZ plane, the aerial vector will be along X direction. So it will be along I cap. So here I can take it as I cap. You can ask me a question, why not minus I cap? Here we are free to choose because it's a square. For a two-dimensional shape, the aerial vector can be in either of the directions. It's always better to take it in the direction of electric. Okay. So what would be the flux through the same square if the plane makes an angle of 30 degrees with the x-axis? This is also an NCERT problem. This we have solved in the class. So what is the answer for the first one? I'll call the electric field as E only. Area, I'm not taking the 10 centimeter and all, I'm just calling it as A square. So what is the angle between both? The first case, cos 0. So it is E into A square. Okay. So what about the second one? E into A square into cos of how much? What would be the flux through the same square if the plane makes an angle of 30 degrees with the x-axis? So why is it 60? See, this is the square. The plane of the square is making an angle 30 degree with the x-axis. So plane itself is making 30 means what will the aerial vector make? It will make 60. So it will be this value divided by 2. So whatever you calculated here, divided with half. So 5 into 10 power 3 into 10 square into 10 power minus 4. So 5 into 10 power 5 into 10 power minus 4. So it is 5 into 10, which is going to be 50. So it is 50 divided with 2, it is going to be 25. Okay. So what is the answer for this one? This is also a textbook only. A conducting sphere of radius 10 centimeter has an unknown charge. If the electric field 20 centimeters from the center of the sphere is 1.5 into 10 power 3 Newton per coulomb, and it points radially inward, what is the net charge on the sphere? So radially inward indicates negative charge. So what is the net charge on the sphere? How will you calculate? Q divided by 4 pi epsilon naught r square is equal to how much? 1.5 into 10 power 3. What is the value of Q? That's what we need to find. So 1 divided by 4 pi epsilon naught is 9 into 10 power 9 into the value of Q is what is to be found divided by R square is, should I take 10 or 20? If you recollect the concept of a shell, right, there are 3 points at which we calculated the electric field. Inside is going to be 0. On the surface is going to be Q divided by 4 pi epsilon naught, capital R square, where capital R is the radius, and the third part is Q divided by 4 pi epsilon naught, small r square. Which one is right? Which one should I use among the second or the third option? I should use the third one. So which one should I take? 20. So it is 400 into 10 power minus 4 is equal to 1.5, or this I can write it as 3 by 2 into 10 power 3. So this will get cancelled twice. So this will go 200 times. Q will be equal to 200 into 10 power minus 1 divided by 3 into 10 power 9. Right, it will be somewhere around 6.67, sorry, 66 point something, right? 66.7 into 10 power minus 10. Right? 66.7 into 10 power minus 10, or 6.67 into 10 power minus 9, which is going to give us 6.67 nanocoulomb. Okay. So this is going to be the answer. Section C. Using Gauss law, obtain the electric field due to a uniformly charged spherical shell. So this is a derivation part. This you already know. I'm not discussing the derivations. This graph and all you know, right? Second. Define the term electric dipole moment. What is it? Product of magnitude of either of the charges into the distance of separation between them. Is it a scalar or a vector quantity? Dipole moment. It's a vector quantity. How is it directed? From negative to positive charge. Reduce an expression for the electric field at a point on the equatorial plane. So this is also known. So what will be the answer? Kp divided by RQ. Right? So Kp divided by R square will come only for potential. So obtain the expression for torque experienced by an electric dipole of dipole moment P placed in uniform electric field E. What will happen if the field were not uniform? So what will be the torque that you are going to derive? It is going to be P vector cross E vector. So what will happen if the field were not uniform? It will experience both torque and 17th. An electric field is a uniform. What is it? A uniform. An electric field is uniform and in the positive x direction for positive x and uniform with the same magnitude but in negative x direction for negative x. So this is also an NCERT problem. E vector is equal to 200 I cap Newton per Coulomb for x greater than 0. And E vector is equal to minus 200 I cap Newton per Coulomb for x less than 0. Right circular cylinder of length 20 centimeter and radius 5 centimeter has its center at the origin and its axis along the x-axis, so that one face is at x is equal to plus 10 and the other is at x is equal to minus 10. What is the net outward flux through each flat face? So what is the flux through? I'll call this as first, second, and I'll call the curved surface as 3. What is the electric field through flux through the first surface? It is E vector into, what is the area? Pi r square. So what is the value of electric field? 200 into pi r square is pi into r square is how much? R is how much? 10. No? X is equal to, oh sorry, R is 5. Okay. Into 25 into 10 power minus 4. Am I right? So what will the answer be? Five pi into, so 5 pi into 10 power minus 2 Newton meter square per Coulomb. What about the flux through the second flat surface? Same value. Okay. So what is the net outward flux through the cylinder? For that you need to calculate the flux through the side of the cylinder. Oh, sorry. What is the flux through the side of the cylinder? Why is it 0? Because the aerial vector is upward, aerial electric field is like this. So angle between them is going to be 90. That's right. So here it is going to be 0. So what is going to be the net flux? It will be 10 pi into 10 power minus 1, or it is going to be, sorry, 10 pi into 10 power minus 2. It will be pi into 10 power minus 1 Newton meter square per Coulomb. You asked me the other day, no? Did you write pi into 10 power minus 1 or only pi? That's good. So what is the net charge inside the cylinder? So for net charge, you have the net flux. So the net flux is there. Just multiply that with epsilon naught, which is 8.85 into 10 power minus square. This total flux is coming only because of the charge that is present inside. No? So total flux is equal to charge enclosed divided by epsilon naught. That is the inside charge. Got it? I think this is the last one. No? Tell me that. This one now. 50 pi into 10 power minus 2. Then your answer should be right. Pi is coming. So it is 5000 into 10 power minus 4. Yeah, 5 pi into 10 power minus 1. Then pi is correct. Then you should get marks. So pi is correct. So 3.14 multiplied with 8.85. Okay. So did anyone lose marks because you wrote pi instead of 3.14? Anyone else? You also? Okay. But you have no exponent beside it, right? Okay. Then you should get marks. How many marks did you lose? This question. Okay. Is your paper here? You left it here? Okay. I'll check it. So what is the net charge inside the cylinder? So this is going to be the value. In the last question. What is this one? State the principle of superposition and use it to obtain the expression for the total electric field exerted on a point charge due to an assembly of n discrete point charges. So state the principle of superposition and use it to obtain the expression for the total electric force exerted at a point charge due to an assembly of n discrete point charges. So this one you know, right? What is the principle of superposition state? The electric field due to a system of charges is going to be the vector sum of the electric fields exerted due to the individual charges. So if there are n discrete charges, the net electric field is going to be E1 vector plus E2 vector plus so on till En vector. This will be there in the solution. You can have a look at it. So second one is 3 charges 10 microcoulomb 5 and minus 5 are placed in air at the 3 corners ABC of an equilateral triangle of side point 1. Find the resultant force experienced by a charge placed at the corner A. So at ABC. So what is the force experienced by the 10 microcoulomb charge? So this is 10, 5 and 5. So this is negative, no? Due to this 5, it will experience a force in this direction. I'll call it as F1. Due to this negative 5, it will experience a force in this direction, which I'll call it as F2. So what is going to be the value of F1 and F2? Both will be the same in terms of magnitude. Why? Because the same combination of charges and the same distance. So if I call it to be F, then how is the force going to be? It will be an angular bisect, right? So answer will be square root of F square plus F square plus 2F square cos, it is 120, because exterior angle is equal to sum of the opposite interior angles. It is going to be cos 120. This is going to be minus half, right? So minus half now, this will get cancelled. This will become minus. So F square and F square will get cancelled. What is that you will be left out with? You will be left out with F itself. So whatever is the force you are calculating individually, that will be the answer. So answer should be K into 50 divided by R square. What is R square? 0.1 square, no? 1 by 100. It will go to the numerator. So this will be 9 into 10 power 9 into 50 into 100. So this will be 450 into 10 power 11. So 450 into 10 power 11 Newton. Please. So 450 into 10 power 11 is going to be 44. But there is no 10 power 11 in the answer. Did I miss something? Oh, micro is there. Okay. Into 10 power minus 12 is there. So 10 power minus 12 means 10 power minus 1 will come. Am I right? So answer will be 45 Newton. This answer. I missed that micro. Saturday. You can write, if you guys have holiday, you can come in the morning and write. 1.5 hours, right? So you can have from 10 to 11:30. That's early morning. Morning 10 o'clock, 9:30 solan. Sorry, one last problem, we'll finish it. So next one. So Coulomb's law states that the electrostatic force of attraction or repulsion, listen, acting between two stationary point charges is given by this value, where F denotes the force between the two charges Q1 and Q2 separated by distance R, and epsilon naught is given by this value. If free space is replaced by medium, then epsilon naught becomes epsilon naught times K or epsilon naught times epsilon R, where K is the dielectric constant or relative permittivity. Okay. In Coulomb's law, F is equal to K Q1 Q2 divided by R square. Which of the following factors does the proportionality constant K depend on? What is the answer for this? So does the value of K depend on the electrostatic force acting between the charges? No, because the force is decided by K. K is not dependent on force. Nature of the medium, because you write 1/4 pi epsilon naught, or you write 1/4 pi epsilon naught times K. So it depends on the nature of the medium. Does it depend on the magnitude of two charges? No. Does it depend on distance? No. So what is the answer for dimensional formula for this? I think someone got wrong for this, no? Like you got it. Yeah. That's right. M minus 1, L minus 3, T power 4, A square. A stands for ampere. Let me check. There is a mistake in the answer key. See, if anyone else got this option also wrong, right? Please let me know. Make a note of this. Let me know. You will have these marks added. In the answer key, the option is not A, it should be C. There is a mistake. What about the third one? The force of repulsion between the two charges, 1 coulomb, each kept 1 meter apart in vacuumness. So what is the answer for this? 9 into 10 power 9. So that's given right only, no? Third one is B, correct. Two identical charges repel each other with a force equal to 10 milligram weight when they are 0.6 meter apart in air. The value of charges. What is the answer for this? What is the answer for this? The answer is given as 2 microcoulomb. Did you get that? How to do this first of all? So force is given. Force is not given in terms of Newton, observe. It's given in terms of milligram weight. So whenever you have this gram weight, right, you need to multiply it with, that is 10. You can multiply with 10. So 10 is this magnitude. Milli is 10 power minus 3. For gram weight, you will multiply with 10. So this is going to be the force in terms of Newton. This will be equal to two identical charges. So this is going to be 9 into 10 power 9 into Q square divided by 0.6 square. 0.6 square is 36 into 10 power minus 2. This will go 4 times. Just take it to the other side. So 100 into 10 power minus 1. So you will get 100 into 10 power minus 3, which is 10 power minus 1. 10 power minus 1 will get multiplied with 10 power minus 2. 10 power minus 3. 10 power 9 will go to the other side. So 10 power minus 12. So you will get 4 divided by 9 into 10 power minus 12 is equal to Q square. Did I miss something? Oh, 9 is gone. No. It is only 4 into 10 power minus 12 is equal to Q square. So if you take the square root on both sides, square root of 4 is 2. Square root of 10 power minus 12 is 10 power minus 6 coulomb. So this is microcoulomb. Answer is 2 micro. Clear with this? But all you didn't get the answer, make a note of this. If you are given the force in terms of gram weight, multiply it with 10. So what should be multiplied? This should be multiplied with the given magnitude of force, right? If they have given it in terms of milligram weight, you will multiply it with 10 power minus 3 into 10. Basically, it is 10 power minus 2. But I've split and wrote it. 10 power minus 3 is for milli. Gram weight is 10. So Coulomb's law for the force between electric charges must, I'll finish this also, then you can copy it. Coulomb's law for the force between electric charges most closely resembles with. That's simple. So wherever I discussed, wherever you lost marks, let me know. So once you finish copying this, we can wind up the class. Okay. If we're done, we can leave.